February 1943. Cold rain hammers the roof of the Naval Torpedo Station in Newport, Rhode Island. Lieutenant Commander Edward Cochrane stands in a workshop filled with half-assembled torpedoes, each one representing weeks of painstaking labor. He is a naval ordnance officer, and he faces a crisis that could lose the war in the Pacific. The numbers are stark. American submarines sit idle in Pearl Harbor and Brisbane, their tubes empty. Japanese convoys cross the South China Sea unmolested, carrying rubber from Malaya, oil from the Dutch East Indies, rice from Indochina. The submarines have the will to fight. They have the crews. What they lack are torpedoes. Cochrane has spent 3 weeks studying the production line. He watches a machinist spend 4 hours hand-fitting a gyroscope housing. The gyroscope itself, a spinning wheel that keeps the torpedo running straight, requires another machinist with 10 years of experience. The depth mechanism, which controls how deep the torpedo runs beneath the surface, needs similar expertise. Each torpedo takes 3 weeks from raw steel to finished weapon. The Navy needs thousands. The workshops can produce dozens. The skilled craftsmen are the bottleneck. Before the war, Newport had enough. Now those men are in uniform, serving on destroyers and battleships. The replacements are farmers from Iowa, shop clerks from Boston, men who have never operated a lathe. Training them to the old standard would take years. The war will not wait years. Cochrane makes a decision that violates every principle of precision engineering. He will not train workers to build torpedoes the traditional way. He will redesign the torpedo to match the workers he has. On the 12th of February, he drives to Detroit. The automotive plants there have been converted to war production, building tanks and aircraft engines. Cochrane studies their methods. At the Ford Willow Run plant, he watches women with 3 days of training install bomber engines using assembly jigs, metal frames that hold components in exact position. The parts are interchangeable. Any cylinder head fits any engine block. No hand-fitting required. He returns to Newport with a plan. The torpedo will become modular. The gyroscope housing will be standardized with tolerances loose enough that any housing fits any gyroscope. The depth mechanism will be simplified. Its 17 hand-fitted parts replaced by 9 components that snap together. The assembly process will be broken into discrete steps, each simple enough that a novice can learn it in hours. The senior machinists resist. They have built torpedoes for 20 years. They know that precision wins wars, that a gyroscope off by 1 degree means a miss at 2,000 yards. Cochrane does not argue with their expertise. He shows them the alternative. At current production rates, the Navy will have 800 torpedoes by June. The submarines need 8,000. Perfect torpedoes that do not exist cannot sink ships. On the 3rd of March, the first prototype of the modular torpedo is assembled. It uses stamped steel parts instead of machined forgings. The gyroscope housing has wider tolerances. The depth mechanism uses a simplified spring system. Cochrane takes it to the test range at Narragansett Bay. The torpedo runs true. It holds depth. The gyroscope keeps it on course. It is not as precise as the hand-fitted model, but it is accurate enough. A convoy is 300 feet wide. The new torpedo can hit a target that size at 1,500 yards. That is sufficient. Cochrane begins the transformation of the production line. He brings in engineers from General Motors to design assembly jigs. The jigs are simple metal frames with pins and guides that hold torpedo components in exact alignment. A worker places the gyroscope in the jig, slides the housing over it, and tightens 4 bolts. No measurement required. No skill required. The jig ensures proper fit. The training program is equally radical. New workers spend 2 days learning one task. On day 1, they practice installing gyroscopes in dummy housings. On day 2, they do it with real components under supervision. On day 3, they join the production line. The old system required 6 months of apprenticeship. The new system requires 48 hours. By the 20th of March, the first production run begins. Cochrane has divided torpedo assembly into 23 discrete stations. At Station 1, a worker installs the propulsion motor. At Station 2, another worker attaches the fuel tank. At Station 3, the gyroscope goes in. The torpedo moves down the line on a conveyor system copied from automotive plants. Each worker performs one task, over and over, gaining speed through repetition. The first torpedo takes 6 hours to assemble. The second takes 5. By the end of the first week, the line produces 1 torpedo every 90 minutes. By the end of March, production time drops to 72 hours per unit, from raw components to finished weapon ready for loading. The quality control system is equally streamlined. Instead of inspecting every part, Cochrane institutes statistical sampling. Every 10th torpedo goes to the test range. If it performs to specification, the batch is approved. If it fails, production stops until the error is found and corrected. This method, borrowed from industrial manufacturing, catches defects without slowing the line. In April, Newport ships 400 torpedoes to Pearl Harbor. In May, 600. In June, 800. The submarines return to sea. In the Solomon Islands, the USS Wahoo sinks 4 Japanese freighters in one patrol. In the Philippine Sea, the USS Tang destroys a tanker convoy carrying aviation fuel to Rabaul. The torpedoes work. Not every innovation succeeds. The simplified depth mechanism occasionally fails in deep water, running 10 feet deeper than set. Cochrane adds a pressure relief valve, a simple fix that takes 2 days to implement across the production line. The stamped steel tail fins sometimes crack under stress. He switches to a stronger alloy. Each problem is solved not by returning to old methods, but by further simplification. By August 1943, Newport produces 1,000 torpedoes per month. Cochrane has trained 400 workers, most with no prior manufacturing experience. The production line runs 3 shifts, 24 hours a day. The cost per torpedo has dropped from $8,000 to $4,000. The Navy has enough torpedoes to equip every submarine in the Pacific Fleet with full loads, plus reserves. The strategic effect is immediate. American submarines begin a systematic campaign against Japanese merchant shipping. In 1942, with limited torpedoes, they sank 1.5 million tons of shipping. In 1943, with Cochrane's torpedoes, they sink 3 million tons. In 1944, they sink 4 million tons. Japan, an island nation dependent on imports, begins to starve. Oil shipments from the East Indies drop by 60%. Rubber shipments from Malaya cease entirely. Rice imports from Indochina fall to a trickle. The Japanese war economy collapses from within. Aircraft are grounded for lack of fuel. Factories close for lack of raw materials. The population faces food shortages. By 1945, Japan's merchant fleet is reduced to coastal barges, unable to venture into deep water where American submarines wait. Cochrane's system spreads beyond torpedoes. The Navy applies his modular design principles to depth charges, mines, and artillery shells. The Army adopts his training methods for tank production. The simplified assembly techniques become standard across American war industry. There are costs. The modular torpedoes are less reliable than hand-fitted ones. The failure rate is 8% compared to 2% for the old model. In absolute terms, this means 80 failures per 1,000 torpedoes. 80 submarines that fire and miss, 80 chances for a Japanese convoy to escape. Cochrane accepts this. 800 working torpedoes are more valuable than 200 perfect ones. The skilled machinists who oppose the changes are proven both right and wrong. They were right that precision matters. They were wrong that precision requires craftsmanship. Precision, Cochrane demonstrates, can be built into the jig, the mold, the assembly process itself. The worker need not be skilled if the system is designed correctly. This insight transforms not just torpedo production, but the nature of manufacturing itself. Before the war, quality meant skilled labor. After Cochrane, quality means engineered processes. The worker becomes interchangeable like the parts they assemble. This is efficient. It is also dehumanizing. The craftsman's knowledge, accumulated over years, becomes obsolete. The machinist who spent a decade learning to hand-fit gyroscopes finds his expertise replaced by a jig and a novice. Cochrane does not philosophize about these implications. He is an ordnance officer solving a logistics problem. His measure of success is tons of Japanese shipping on the ocean floor. By that measure, he succeeds completely. In November 1944, Cochrane is promoted to commander and assigned to the Bureau of Ordnance in Washington. He leaves behind a production system that runs without him, proof that he has built something larger than his own expertise. The Newport Torpedo Station continues to produce 1,000 torpedoes per month until the end of the war. The final accounting is stark. American submarines fire 14,000 torpedoes during the Pacific War. They sink 1,300 Japanese merchant ships, totaling 5 million tons. This represents 60% of Japan's pre-war merchant fleet. The submarines also sink 214 Japanese naval vessels, including 1 battleship and 8 aircraft carriers. The cost is 52 American submarines lost, with 3,500 men killed. Cochrane's torpedoes do not win the war alone. They are one element in a vast industrial and military effort. But they are a necessary element. Without reliable torpedoes in sufficient quantity, the submarine campaign fails. Without the submarine campaign, Japan retains access to the resources of Southeast Asia. The war lasts longer. More men die. After the war, Cochrane returns to civilian life. He works as a manufacturing consultant, applying his methods to peacetime industry. He dies in 1967, largely forgotten outside naval circles. His obituary in the New York Times is 4 paragraphs long. It does not mention torpedoes. The production system he created outlives him. The principles of modular design, interchangeable components, and simplified assembly become foundational to modern manufacturing. Every smartphone, Every automobile, every mass-produced object carries the echo of his work. The craftsman's intimate knowledge of materials and tools gives way to the engineer's systematic design of processes and jigs. Whether this is progress or loss depends on perspective. The world gains abundance and efficiency. It loses the satisfaction of mastery, the pride of the craftsman who knows every part intimately. Cochrane himself likely never considered the question. He saw a problem, found a solution, and moved on. The torpedoes worked. The ships sank. The war was won. For an ordnance officer in 1943, that was enough.